Hello. Hi, everybody. Thank you so much for being here. So we have like a boatload of knowledge we're about to like drop on you today. So I hope you had your coffee and or your siesta, because we're going to talk kind of fast, and for that I apologize in advance. Hey, this here is Susan.
Hi, and this is Todd.
Hi, and we are here today to talk to you about Firebase Offline. What works, what doesn't, and what you should know. But you know, Susan, my phone has like 3 bars on it right now. Should I even care about offline?
Ooh, what a leading question,
It is
Todd.
a good question.
Of course you should care. We know that when we're building out apps, we're often on a good Wi-Fi system, but we want our apps to be able to handle situations where our users go offline, maybe a crowded place or they go underground. And so we want to build out our applications to handle this case.
All right, well, then I guess I will care. Thank you. So the general philosophy when it comes to offline support is that Firebase is not an offline-first platform, but we are offline tolerant. So what does that mean? Well, let me explain. The idea is that you can take an app that is powered by Firebase and go on like a long plane flight from San Francisco to Madrid, or take it on like a super long elevator ride, or take it with you in a hike in the mountains, and your app will generally continue to work. Yes, there might be a few degraded experiences here and there, but it will still generally be functional. But it is not an app where you could expect to provide either an offline-first experience or an experience where your user stays offline for weeks or months at a time and maybe syncs with Firebase once a month, once a season, right? And you will generally see that philosophy in most of our products. Now, the good news here is that most of this offline support mostly just works without your having to do a whole lot. Most of our products use some combination of either caching things locally or performing exponential back-off and retry, and that's when Gmail says, like, oh, I'm going to try and connect in 2 seconds. OK, now 4 seconds. OK, now 8 seconds, and hopefully eventually it does. So between these two strategies that Firebase uses, we're able to provide you with a fair amount of offline support without your having to do a whole lot. And that's nice. But there are ways you can affect this offline behavior in both positive and negative ways. And as always, I find that the best way to make sure that you are doing the right thing in the right circumstances is by understanding how things work behind the scenes. But maybe all this would make more sense if we had a more concrete example. So let's create an app with the power of our imagination, because we didn't have time to actually make one.
So we love olives. I've actually only been eating olives here in Spain. It's been delightful. And we know that Spain is one of the world's largest olive producers, so we thought we would make an app for those olive farmers so that they can take photos of their olive trees and upload them to the cloud and have a history, like a database full of olive tree photos to compare different things with.
That sounds like it might be useful if you're an olive farmer. And it just so happens that Olive Journal was built in our imagination.
That's surprising.
What? Yeah, using Firebase. And so there are a number of Firebase products that are powering our apps behind the scenes. We got like Auth so that our users can sign in. And we have Cloud Firestore, our NoSQL database in the cloud that stores a lot of like our farmers' like readings and measurements and notes that they want to take about their trees. Our images, our large binary objects, are stored using cloud storage for Firebase. And of course, we've got a combination of analytics and performance monitoring and Crashlytics to find out how our users are interacting with their app, how well it's performing, and if they are running into any issues. But this app is primarily used by growers that are touring their olive groves in the countryside. And while these olive groves might be known for their like majestic beauty and their rolling hillsides, they're not always known for their strong and robust cell phone coverage. So what happens when one of our farmers attempts to use Olive Journal in the middle of an olive grove and they are not connected to the internet? Well, let's find out by looking at all those Firebase products that are powering our app, and we'll see what happens. And let's start with Firebase Auth. Susan?
Cool. So Firebase Auth is Firebase's identity as a service product. It allows users to log into their application. It keeps track of the logged in users, and it allows them to sign into services like Firestore and storage. So let's talk a little bit about how this works. So you have an app, your user logs in, it talks to the Firebase Auth server, in exchange gives you a token and the logged in user. You then use that token to talk to services like Cloud Firestore. You also have access to the user object with things like the email, the user ID, and the photo URL. That token expires after an hour, but we refresh it underneath the surface. So let's talk about what happens when you go offline. When you're offline, you only have access to the user object, so the email, the user ID, and the photo URL. And let's talk about what doesn't work. You can't log in because you can't talk to the server. So anonymous login doesn't work here. You have to be able to talk to the server to log in. And you can't talk to this Firestore or storage because, once again, you're offline and you can't talk to the server. So let's talk about the gotchas here. So the main gotcha is not being able to log in. So if you're not logged in already when your app goes offline, you won't be able to log in. The second kind of related gotcha here is called auth persistence. It's a setting that you can configure, and it tells you how long you stay logged in. So if you have an app that's like used, banking app maybe used in a library, and when you close your tab, you want the user to be logged out. If you're offline, you won't be able to log them back in because you set your auth persistence to be none to be a little bit more secure. So that's kind of a trade-off you'll have to consider when you're thinking about offline experience and security.
All right. Let's move on to Cloud Firestore, because this is the primary driver of functionality within our app. And luckily, it is also one of the best in terms of providing a smooth offline experience. So we're going to break this up into two parts. First, we're going to talk about reading data, in our case, using real-time listeners, and then writing data to the cloud in Cloud Firestore. So why don't you talk about some reads?
Yeah, so when you read data from Cloud Firestore, two things happen. The first thing is that we get a callback from the cache. So your data comes back immediately from the cache if you have data there. The second thing that happens is we go to Cloud Firestore to get the data there, to see if there's any updates or anything like that. If the data is the same, the SDK is smart enough to not send you a second listener, so you only get that first firing. However, if the data is different, the server sends you back the new data, and you get a second listener that fires, and your cache updates with the new data. To the user, this might look like there's two reads coming in, but to the user, it won't look like there's two reads coming in, excuse me, because it'll look like it's just gradually filling in, but it's actually two reads. So what happens when we go offline? Well, we still get that first read from the cache, and so that information comes in, but we don't get the server read. If you're intermittently offline, you go offline, you come back online, maybe you're in a spotty area, you'll get that second read a little bit later, so it'll have that like slow fill-in process. But the thing to notice here is you can actually also query your cache differently than what you had initially queried it. And also, since you can do that, your cache data might not be exactly the same as your server data. So you might have information in your cache that is different from what you have in your server. So your results might look a little bit different. I think this would be a little bit more clear in an example. So let's go through this with our olive trees. So let's say I've decided to look at all of my olive trees in Spain. And I have those in my cache. And then I ask my app to tell me the tallest olive trees. If I'm offline, I'll only get back the tallest olive trees in Spain, even though in my server, I have olive trees that are taller in Greece and Italy. Italy. So just be aware that the data on your server might be a little bit different. So that's reads. Let's talk about writes.
Let's talk about writes. So when you write data, a couple of things happen. Your data is written to the cache right away. And sort of like with our real-time reads, when you write data to the cache, that will once again fire off your real-time listener, giving you back your updated data nearly right away. This happens locally. It's very fast. But now in the background, your data is still being sent over to the real Cloud Firestore database that's hanging out there in the cloud. Now, this data will get updated in the cloud, and Cloud Firestore will once again send that document back to the client. Now, like before, if these two documents are exactly the same, by default, Cloud Firestore will quietly ignore that second callback. It says, I've seen this already. I won't bother the user. You can change that behavior if you want, but by default, it won't tell you about it. Now, the benefit of all of this is that you get some really nice latency compensation, right? From your user's perspective, it looks like all the writes that they have performed in your app happen right away because you're not waiting for that round trip to come back from your server. So it's really nice. It's a fun little benefit. Oh, yes. So what happens when you go offline? Well, basically, just the first part of that process works. So for writes, once again, that local write will trigger your callback right away. Your real-time listener will fire with your cache data, right? And I should note that in the case of document modifications, not just new documents, we kind of play back local writes on top of your original data. That original data doesn't get modified until we get confirmation from the server that these writes have gone through. So when network connectivity is finally reestablished, those writes will be sent down to Cloud Firestore in the cloud in the order that they were written within your app. Once that data has been received, Cloud Firestore will verify it and send back your new documents with your data back to your device. And again, if this is already what we have cached locally, if this looks exactly the same, by default, the local SDK won't tell you about it, but it will go ahead and confirm those pending writes and bake them into your cached data. But of course, in some cases, these updates might include new data. Maybe other people have written to those documents in the meantime. And that's fine too, right? If this data looks different than your cache, that will just sort of, once again, update our cache and trigger our real-time listener. So speaking of that cache, I bet you people are wondering just how large it is.
Yeah, I'm definitely wondering, and the answer is on mobile and web or mobile devices, it's 100 megabytes, and on the web it's 40, and that's actually configurable in your settings. So you could actually set the cache size to be unlimited, which would remove all the cleanup, and it could bloat your app out. But it is a setting you can configure. The other really cool thing about the cache that I was curious about is if you have an app and you're frustrated, you swipe out of it, your cache actually stays in Firestore, so you can go back into that app and access the information.
All right. So let's talk about a couple of gotchas here. The first one that I've probably seen most often in the real world, and maybe even in our own sample apps at some point, is that write completion handlers don't fire until your write has been confirmed by the server. And what does that mean? Let me explain. So right in here, you can see an example of a write where we are adding a new journal entry to Cloud Firestore, and in the callback, we're saying, okay, now go ahead and dismiss that new, journal entry view controller. So the problem is that if we were running this app while offline, that callback would never fire. And from our user's perspective, it would kind of look like our app is frozen because this view controller is never going away because we're waiting to get that response from the server. And that's bad. You don't want your app to look like it's frozen. That's something I learned. Don't.
Surprise.
It's an anti-pattern. Don't have your app frozen. So the right thing to do here is actually just dismiss that dialog box essentially right away. You don't have to dismiss it in your callback. Because remember, as far as our app is concerned, those writes have happened immediately. They've been added to the cache, and you are allowed to work with those right away. So save the callback for things like maybe changing the appearance of a journal entry to show that, yes, this has been confirmed and written to the cloud, or logging any errors that are returned by your server. The second gotcha is that currently this on-device cache is not indexed. So we like to say that Cloud Firestore queries are very fast because we index every field in every document in every collection, and that is true in the cloud. But on your local device, there is no indexing right now. So when you do a search, we basically have to unpack and scan every document in the collection that you are searching through. Not only that, but remember how we replay all those pending writes on top of your data? We have to do that as well, which means that if your local cache is too big or has too many writes, or you're just running on a sort of slow or old device, this can run quite slowly. Now, you can fix this by not preloading your cache with too much data, even if you think your user will be offline. This will probably do more harm than good. I know some developers are like, I'm just going to go ahead and download the entire database and get millions of documents when we first run, in anticipation of maybe having a better experience, but this will not work. Don't overload your cache. Kind of trust that your user will probably be making queries similar to ones they've made in the past, and let your app or let your cache sort of develop naturally based on your user's natural use pattern. You can also, by the way, adjust your cache. Go ahead and keep your cache size reasonable if you notice that your user is running on a slower device, right? If you detect that the device is old or slow and maybe you think the cache is going to take a while to run, make it smaller. All right, so now let's talk about cloud storage for Firebase. This doesn't have quite as robust of an offline solution as Cloud Firestore, but it is still smart enough to generally do the right thing and not break your app, which is, good. If you're not familiar with cloud storage, this is a service where you can save large binary objects to the cloud, like, images or movies or PDFs or big data streams. And you generally do this by specifying a reference, which looks a little like it's over here, looks a little like a path, and then asking Cloud Storage to go ahead and upload an object to that path. Downloading is very similar. Start with a reference, which once again looks like a path, and then go ahead and download it, and then in our case say, hey, go ahead and convert that data stream into an image. So what happens when you go offline? Well, if you have an app where you have some kind of pending upload, generally speaking, Cloud Firestore will retry this with exponential backoff until it finally does upload. And this does generally continue working even if you were to switch to another app and then come back. When you come back and this app is once again in the foreground, it will go ahead and try and redo any pending uploads it has. However, if your app is killed or suspended and then starts up again, this behavior is also killed. Your app doesn't remember about these pending uploads, right? And if these image files are something that you've only saved as local variables, for instance, that data is also lost. So if we assume that keeping these photos are important to the users of Olive Journal and we want to fix this, what would we do? Probably something like this. When our user takes a photo, go ahead and save that photo first to local file storage. Along the way, go ahead and keep a list of files, again, stored locally, that we want to upload to cloud storage. Then, once a photo is successfully uploaded in cloud storage, the SDK actually has a method that says, upload from local file, which makes this pattern fairly easy. Once it's been uploaded, go ahead, delete the local version, and remove it from our list. And so the nice thing here is that when your app is killed and restarts, well, we still have a record of those local files, and our app says, oh, look at that. I still have some pending uploads, and it can go ahead and try uploading them again. Let's talk about downloads.
Yeah, so downloads work nearly the same. They have an exponential backoff to try and get files from the cloud. So the thing to note here is that storage doesn't have a cache like Firestore does. So if you want that functionality, you're going to have to build out your own. It's fairly easy to do, but we have some simple open source solutions that do this for you. So in Android, there's the Firebase UI and Glide, which allows Glide to understand Firebase storage references, the same as it does URLs. And on iOS, there's a library called Firebase Storage Cache, which creates an NS cache to store images downloaded through cloud storage for Firebase. The other thing you could do here to kind of create a cache for images is talk to storage and get a publicly accessible URL, and then use that publicly accessible URL to use an existing library that can cache images loaded through URLs. So a library might be Glide or Kingfisher or Pin Remote Image. The drawback here is that if you're already offline, you can't get those publicly available URLs because you have to be online to get them. So let's talk about the gotchas. The first storage gotcha is pretty similar to the Firestore gotcha. It's about this completion handler. So if you're waiting to close a dialog for confirmation that you uploaded your data to cloud storage, if you put it in that completion handler and you go offline, it'll never close the dialog. So maybe you say, write to Cloud Firestore to be like, hey, image uploaded, here's where I saved the file. If you're offline, you won't ever get to that point. And so the solution is just to take the Firestore write or whatever you have outside of your completion handler and just assume that the data was correct. Then in that completion handler, you can say, write to Firestore and be like, upload true, so that you have a reference that the data was uploaded or not.
All right. Now let's talk about all the measurement libraries, all of them, or at least 3. Analytics, performance monitoring, and Crashlytics. And I'm grouping all these together because 1, I only have about 5 minutes, but 2, they generally follow similar strategies. So in general, data that you are recording using analytics, Crashlytics, or performance monitoring is already stored locally in a cache. Because if you think about it, at least for like the analytics and performance monitoring data, like we're recording this stuff constantly, and we wouldn't want to be constantly sending this data, off to Firebase's servers because that would be a terrible drain on your user's battery. So instead, we already store batches of this data locally, and then go ahead and upload them during regular intervals or certain moments in your app's lifecycle. The specific moments depend a little bit on your device and on your library. One note here is that on Android, all this uploading is done by Google Play Services, which means it can send this information even if your app is not running. That's why, for instance, if your app were to crash on Android, you get that crash data right away, because Google Play Services is able to see that crash data and upload it for you. On iOS, we have to wait for the user to start up your app again before your app can go ahead and upload that crash data to our servers. So what happens if we can't connect? Well, basically, they all follow kind of the same strategy, which is exponential backoff and retry, either while your app is running on iOS or Google Play Services does this for you on Android. And in the meantime, we keep accumulating data from these libraries up to a limit. And what is that limit, you might be wondering? Good question, because it's on the next slide. It's about 10 megabytes of data in performance monitoring, about 100,000 analytics events, and about 9 crashes. All these subject to change, so all of you taking pictures right now, don't get angry when this changes. One interesting note is that on analytics, if we hit this limit of 100,000 events, which admittedly does not happen very often, we will stop collecting the more recent events and keep the older events. And this is because for a lot of developers, the one thing they really care about most when it comes to analytics is that first open event and the attribution data that's associated with it, and maybe some of those sort of initial going through your app's lifecycle events like signing in or creating an account or completing the tutorial and that sort of stuff. And so if we have to make a choice, we will keep that data and sort of drop the more recent events. But again, it doesn't happen too often. As for gotchas, I think the biggest thing you need to be aware of is most of these libraries, and this is a technical term, they kind of freak out when they encounter data that's too old, right? Because they need to ask themselves, all right, is this data actually really old? Or, because your user has been offline for a week or a month, or do they not trust your system clock, right? Because both these things are equally likely. And a lot of these libraries do some clever work kind of behind the scenes to adjust for clocks that might seem off, but they're not perfect, and at some point, they're just not sure what to do with a date that seems really old. Crashlytics will generally address this, by the way, by just changing the timestamp so that it looks like the crashes happened today. They're like, it's fine. You probably want to see this crash data anyway. Performance monitoring and analytics, they'll generally discard data that looks like it's more than 72 hours old. So again, if you have an app where you're expecting your users to be offline for weeks at a time, which again is sort of not a pattern we recommend with Firebase, some of your analytics data is going to get lost, and your app's usage might seem lower than it actually is because some of that old data will get discarded. All right, well, let's see if we can sum up everything that we've learned in the last 25 minutes.
Cool. So when you're offline, things mostly just work. We have 2 strategies for doing things. It's caching things locally or exponential backoff and retry. But Firebase is designed for occasional offline moments. It's not offline first. So if you need completely offline experience, it's probably not the right tool set for you. Let's go over the gotchas. So for Auth, the main gotcha, can't log in. Right. You're offline.
Watch out for those Cloud Firestore write callbacks. They will not fire if your user is offline, so don't have that view controller up there forever.
Cloud storage doesn't have a cache, so you'll need to write your own.
Or use a third-party open source library.
That would be fine too.
And our measurement tools, they're just a little suspicious of data that seems too old. So with that, we are out of time.
Thank you so much. I hope, we know it's a lot of information, but if you want to take anything out of this talk, I hope you learned something about how offline works across different Firebase products, that you feel empowered to build with offline in mind, and maybe go check out how your existing app works. See if you can actually close dialogues when you're offline.
Yeah, the answer might surprise you. If you have questions, please go ahead and rewatch this again on YouTube at 0.5 speed, because again, I know we spoke kind of fast. And otherwise, if you're here at the event, why don't you meet us at the Ask Firebase Lounge, where we can take this conversation offline.
Got him.
We did it.